Hello viewers, Alan here, welcome back to the workshop. So I started this video with a look at what it is that I'm hoping to make. So at the time I'm actually recording this bit, I haven't made it, so I don't actually know how it's going to turn out. So I saw one of these double pendulum things and they fascinated me, so I thought, it looks easy enough, I'll make one of those and have a play. I didn't want to spend any money on it, so it was a case of raid the scrap box and see what I could find. Right, well, I've got a bit of bar stock and something which can be the column. I need a base. That's one candidate. Yeah, I think this one will get the job done. Yeah, go with that. So we've got a base, the column, enough material for two of the arms, so I've got to scrounge up another piece of that. Now the other thing I'll need is something to put a core in the bottom of the tube. I think we found a volunteer. So I think that's enough to get started. I'll prepare a set of drawings based on these materials and get into some machining. So we've got a few pieces to make, and I think I'll start with the column and start by squaring the end and bringing the column to length. Obviously the length of this isn't crucial, just a hole pointing up in the sky. So I've drawn it to be 450. We're currently on 453, so we'll take 3 off. So I think another 1.5 is going to get us close enough. Yeah, you won't be able to see that, but we're spot on 450. So happy with that. Just a bit of deburring. Right, so I think for the next bit I'll mount this and get it cleaned up. So I've got a face here which seems reasonable, and it's square there and square there. So I'll use that to start with. This upper face is all over the place, so certainly this is the face that's got it's just a rude hacksaw cut. So anyway, I think I'll mount that in there. And give it a mild headache. Right, I've just got to choose a cutter now. I think I might as well use this guy actually, at least to start with. Right, so I'll use the quill DRO to find which is the lowest corner. We'll zero that. So we'll go again, and perhaps it'll be enough to get this face cleaned up. I think that's probably cleaned that up well enough. I was going to run the fly cutter over it, but I don't think there's much point. It's going to be hidden inside the tube anyway. So now I've got a reference face to work off. So that's lopped that piece off with the bandsaw. So now I'm just going to trim this length, that dimension. I'll do that again with the bandsaw. So this should be the final pass to bring this block to size to fit in the end of that tube. Right, well let's hook it out and see if it fits. So we've got a good fit that way. It's a bit snug that way, but still goes in. And I dare say though it'll bind up in the corners a little bit. But if it starts, it'll knock in. There we go. It will start. It's just got to get it dead right. So very happy with that. And there we are, tapped in. Right, so now I've got to put 4 holes through the face of this to lock the column to that block. And make sure it doesn't mess around while I'm doing the drilling, I'll put a clamp on, put a bit of squeeze on it to make sure it keeps its position. Okay, well, let's go. Oh, and the reason I decided to drill through the column and the block in one go is just that there's some possibility for the drill to wander off course, and I thought, well, in this case it's easy to do. I mean, the DRO is pretty accurate. I don't usually have a problem getting holes like this to line up, but I don't see any downside to drilling through both of them at once in this case. Alright, that's the first one. So we can make sure this bugger doesn't move now. Oh, well, we could if we could get that in. Let's move it on to the next hole. Right, now you can get in there, can't you? Right, I'll do the other 3 holes. Now that's my 4 bolts. If I was making it again, I probably wouldn't bother putting 4. I can't see why 2 wouldn't be enough. These in real life look much closer together than they did as holes on a piece of paper. Anyway, can't see it being a problem. So moving on to the base plate, I've got to put a bolt pattern, a 4-hole bolt pattern in this for the block in the bottom of the column for 4 6mm socketed screws. So 4 6mm holes and 4 counterbores. Let's finish that. We'll switch the drill out for the 10mm end mill. So when there's 7mm deep counterbore on each of those 4 holes. A rat's nest there. A test fit. Oh, she's a little bit tight. Perhaps this screw's got a particularly big head. You can get a different screw and try it out. So it turns out all the screws I had heads that were at 10 or even a couple of points over. So I just turned 4 down to 9.5. Let's fix that problem. So do the other 3. So 4 holes drilled, got to tap them now. Alright, well this piece fits nicely on its bolt pattern. So hopefully it will also fit nicely in here. It's a little bit snug, so it might need a bit of persuading. There we go. Oops. Let's just wind these in a bit. Keep this lot under control. So we just give this a gentle nudge. Hopefully that's enough. Oh, God. What else can I drop? So I recovered the bolt that went on the floor, and all of these guys go into their spots happily enough. And I'm going to assemble it first up with plain nuts. When I do the final I'll put lock nuts on, but for the moment plain nuts will get the job done. So let's just snug those up. And of course it's wobbling around a bit at the moment because I haven't tightened up the ones underneath. I'll do that now. I think you'll see that's killed all the wobbles. That's as stiff as if it had been welded actually. Anyway, if I had my time again I'd have spaced these out a little bit more vertically. I had a big enough piece of material, I don't really know why I didn't, but anyway. Yeah, it's fine. So that's the most of the stand done. I think I'll do the hole at the top here next, and then the stand will be finished. And I also have to make a support piece to fit inside here, so when this bolt gets done up it doesn't crush the tube. So it'll be a little bit of lathe work. So I'm getting set up to make the pivot bolt here. Essentially it's 8mm long at each end, threaded at each end, and one half of it will go through the column and have a nut on the back of it. And then there'll be embedded in the middle here a 12mm across the flats nut, and then the bearings and all the rest of it on the other end. I want to rough it down to 16.2 because that's the diameter that contains the 12mm across the flats hex that I want to do. Now I think we're on 17 at the moment after a quick roughing. Yep. So let's take it down to 16.2. So we'll see if we finished up somewhere near 16.2. It's not a critical dimension, but always good to shoot for these things. 16.201. I'm happy with that. Right, so this should be the final pass for this end to get it down to 8mm for 48. So hopefully we finish up somewhere near 8. This is for a bearing to slide on. I guess that'll do it. Alright, well let's see how the bearing fits on there. What? Look at that. It's like a what's it in a shirt sleeve. What's going on? Let's check the diameter of that. That's ridiculous. My shaft wasn't anywhere near that far out. Well, I'll check this bearing, as you can see. And the wretched thing is about 0.1 oversized. That's crazy. I've never seen a bearing so far off its designated size. That's ridiculous. It doesn't have any maker's mark on it. I'm not surprised. They wouldn't want to be known by it. I'll go and find another one. Right, well this is an FAG bearing. Oh, yeah. That's what we want. Not that other nonsense. Yeah. Alright, but anyway, we've got a result. Okay, so I've got this diameter sorted out for the bearing. I'm about 7.98 or something here. But I want to reduce this a little bit further because I'm going to put 12mm of M8 thread on here. So I'm going to take that down to 7.95, make it a bit easier to run the die on, give myself a bit of clearance. Right, let's get some threads on this guy. It's pretty easy doing that with a tailstock mounted die. I mean, the reason I decided to do it that way, by the way, is that the thread pitch is 1.25, and that not being a factor of my lead screw, I would have had to either use the thread chasing dial or keep the cutter engaged, and it was just easier using the die. Also, it's not a terribly critical thread. I'll just clean that up with a chamfering tool and get a nut, make sure that's alright. Yep, like I bought one. So the next thing is to cut this off to length and then turn it around in the chuck and do a similar set of features on the other end. So I have to rough this down, heading towards 8. $7.996. Well, I'm pretty happy with that. Alright, so all I've got to do now is a bit of chamfering and put the thread on the end. Set up to cut the hex pattern now, and the OD of that piece is 16.2, and I'm aiming for a 13mm across the flats. So I'm going to take a 1mm cut off each of two opposite sides, measure up, and see how much more needs to come off. Let's see what we've got at that. It's sitting on 14.03. Actually, I suppose I could just go with a 14mm across the flats. Just go with that. Huh. Looks like we're finished. Get a spanner and check it. That's 14. It's got a pretty good feel. Alright, so let's clean that hex gun up. Then we do a trial assembly now. Oh, that's turned out pretty well. I've made a spacer to go in there so that the bolt won't crush the tube. And that means the column's done. Right, so the only piece left to make on this drawing sheet is the spacer block between the two upper arms. Now I'm looking for a piece that's 32 by 32 by 16. Now I haven't got any offcuts or little bits, but looking in my rack of bar stock, I think I've got something. Yeah, it's 25 by 50. So I better get out of that, I think. So after dinner last night, I got to thinking about the wastage which would come into play if I took my 32 by 32 by 16 piece out of this bit of bar stock. And I did a quick sum to see what the wastage would be if I took that same piece from a bit of round bar. And the round bar would need to be about 42, I think. Well, I've got this which is 2 inches, and it turns out that the amount of wastage, if I cut a 16mm disc off this and then turn that to a square, the wastage is half the wastage from that, which rather surprised me. Of course, that's assuming that all the wastage is swarf. it would be possible to cut this to get one piece that's potentially useful. But anyway, so I was looking at my stock of bar ends to see whether I in fact had a piece like this, and I realised I had this. This is the centre of an old pulley. It's been hanging around, but in fact I can get my piece out of that with very little wastage. So I'm thinking that's what I'm going to do. So to help me hold this piece in the chuck, I'm going to use the backstop. I can't go berserk over tightening the chuck because I don't want to break off this diameter on the back here. Anyway, that should hold it well enough. So that's got that mounted, but I need to check whether I've got clearance on the back here, on the back side of the tool holder. This is good in many ways, but this is one issue I'd be watch out for. But yes, that will be okay. Right, the OD here is 47 and I need 45 to get my square out of it. So I'm going to start by just taking this piece of stock back to that diameter, as close to the chuck jaws as I can get, and then that should give me a good start point. That's a bit wobbly. I think I'll see if I can get this thing running a bit truer in the chuck. Yeah, I think that's a bit better. Make sure I've got my 16. Yep, that's okay. Yeah, so I think my next move is going to be turn it around in the chuck and get rid of this lot. Might be useful for something maybe one day. Oh, you've got lots of metal to play with. Got 20 there, I only need 16. So we'll clean this face up. Which way around do I want to do this? I think what I'll do, probably what I should have done before, is clean this face up because there's some sort of a taper or chamfer there, and then bring it to width by taking the other side down. Actually, I think before I turn this round I might as well bore this out. This hole needs to be taken out to 18 diameter. Better put some lubricant in the hole, I think. Anyway, we're going to shoot for 17 this time. Actually, I must say 16.5. That's halfway to the end goal. Right. Did we get 16.5? I'd say we did. I don't know whether you'll be able to read that, but we got within 0.01 of 16.5. And this is only a clearance hole anyway, so we'll just go straight to final size of 18 now. Looks like we're going to finish up with a little bit of this keyway in the mix. Doesn't matter. Huh. So we might have got lucky. Oh no, there's a little bit of the keyway there. Like I said though, it doesn't matter for this. I'm only interested in it as a spacer. There won't be anything in contact with that inner diameter. Alright, well I can take that out and start turning from the other side to bring it to size. And hopefully we've finished up on 16. And maybe you can see, maybe you can't, but we finished up right on 16. So happy about that. So that's finished the lathe work on this piece. It's over to the milling machine now to square it up and drill 4 holes in it. Okay, so I've got my bullet mounted in the device. It finished up being 47.5 OD. So to take a 32mm square out of that, I've got to take basically 7.75 off the sides. Now what I'm intending to do is take 7mm off this, we'll call this the first side, and then stand it on a 7mm gauge block and take 7 off the other side, off what will then be the second side, and then out with a square and repeat for the other 2 sides. So then I should finish up with a slightly oversized square and take it from there. That's the plan. So touch off first. So we just touched off on the back edge there. I think what I'll do my first pass at 4 depth and the second pass at 7 deep, and we'll see how that works out. I don't know what speed to use. We're on 800 at the moment. We'll see how we go with that. I'll go a bit faster actually. Maybe 1,000. Well, it seemed to cope with that alright, so we'll go up to, or take it down, take the cutter down to 7. So since it coped with 4, hopefully it will cope with 3.5. Well, that's the first side done with no apparent drama. So I changed my mind and decided to do the first cut at 90 degrees instead. I'm not sure whether it makes any difference. And so, with 4 holes poked through this thing, the spacer block's finished. Moving on to doing the arms, I've cut 3 pieces to appropriate length. I did find another piece I could use. It's for the third arm, and I'm ready now to start boring some holes. I was going to do the curved ends first, and I realised it actually be better to do the hole patterns first, because the curling or the rounding on the end is a finishing feature and dimensions aren't important. But I am wanting to locate the holes accurately. Anyway, for this arm I need a hole 22mm diameter that goes right through, and this bearing will basically be pushed in and sit in the middle of the thickness of the material. Now normally I'd do a boring operation for that, but I just thought for the hell of it I'll try using an annular cutter, and I did a test cut and a bit of scrap, and I found that the size hole, but the hole was actually very close to size and is actually a perfect light push fit for the bearing. And I thought, okay, well that's going to be a bit faster doing it that way than getting the boring bar set up for it, so I thought we'd give it a try. And I can't get the bearing out. Well, let's see what happens. I guess if the worst comes to the worst, I can always turn the bar around and put another hole up this end. Get rid of some of this swarf. I can't do a test fit at half race distance because it leaves a core, so we just got to carry on trust. Right, we're out all the way through. I'll worry about getting that out in a minute. Let's see if the bearing falls through the hole. That's going to be really nice. That'll push in there just nicely to the middle of the... That's amazing, isn't it? These can cut so accurately at 22mm in this case. Right. Well, of the three 22mm holes I've got to do, that's the only one that I can bore all the way through. So the others I will have to use the boring bar for. But that was quick and easy. And while I had this set up, I did a 5mm hole here. This is for a lock pin to make the lower half of the pendulum and the top half of the pendulum act as a single unit. They'll become clearer later perhaps. Right, so I've drilled all the common holes now. These 5 are all drilled at 5mm on this side and 4.2 into that piece because there'll be M5s tapped into that. These are 18mm all through, and that's will be opened out, leaving 3mm behind to create a pocket for the bearing to sit in. And up this end, this one here is 8mm, but on the other side here it's 5mm for an M6, and you'll see how that works later on. So time to take this top one out and tap the holes in the lower one. And probably time to have a bit of a clean up too. Okay, so I'm boring the pocket for the bearing here. The hole that I bored earlier was 18. I'm opening it out to 22, 7 deep, and the bore at the moment is on 21, and I've got the boring bar set to take another millimetre off the diameter. So this hopefully, well, this is probably the final pass, but I might have to do a spring pass afterwards. Fingers crossed. Alright, well, let's see what we got. One thing about boring, if you take too much out you can't put it back. It's a bit nerve-wracking. It looks to me like we're sitting on pretty damn close, about 0.01 under 22. See whether the bearing falls in the hole. I think that would press in. It started. Don't want to come out now. Oh. Oh, there we go. Well, I think that I've probably got just about the right size there. I'll measure it again. Yeah. Almost exactly on 22. So I think I'll leave that alone and call it done. Alright, well that started in there, and I think we've got the fit just right. I think you'll be able to see I don't have to put very much force into this to press the bearing home. There we are. It's not going to fall out. So this is the other upper link, and I think you can see that the boring head's done a very neat job of cutting out that bearing pocket. so I can get that bearing installed now. So I'm moving on now to doing the finishing on these arms or links, and I want to round them. And I could have done it in a belt sander, but I've only got really quite a coarse belt at the moment, and I didn't really want to use that, so I thought, oh, I'll do it on the rotary table. So it's a bit more interesting anyway. So getting hold of these things so I can do that, it was a bit of a head scratch, but I think I've got something sorted now. So this is just a bit of spare aluminium bar, and you can see I've got it held down to the T-slots by a couple of countersunk screws. And the reason I'm going down this path is that I can centre on this one, on that hole, for my 16 radius rounding, but this guy doesn't have that feature, so I needed some way of finding the centre of rotation. So what I've got set up here is this thing's a snug fit in that fixture, and so if I put this there, that's an 8mm dowel, same as the hole obviously, and bring it down. I can press that in there, a very positive location. So that locates this one, and so I can transfer that location to this one, which doesn't have the hole. I set it up so that this spacer block can be used. So now when I take this one out, I can just put this one in up against that, and it's restrained within that fixture. So I think that should work out alright. The fixture will be a bit sacrificial because the cutter's going to come around and cut through these upstanding bits. So be it. So I'll get this dowel switched out for an appropriate milling cutter, end mill. So time to see if I can do this without messing it up. Well, that seems to be working alright, apart from where I stopped. Oh, never mind. So we get set up to come back the other way. Right. Well, that looks like a pretty good job. Happy with that. Time to take this one out and switch it over. Oh, that's not bad. Not perfect, but it's pretty good. Nothing there that a bit of emery paper won't clean up. So this is the one that would have been quite hard to do without this fixture not having a centre point. These clamps are pretty good, these toe clamps. I don't know where they came from, part of an auction lot from somewhere. But they're very low profile and quite rugged. So I might see if I can tune my settings a bit more. So I did get a little bit of undercut on that last one still, very little, but you can really see it, which is annoying. Alright, let's have a look. I'll think about what I might have to change. Off we go for the last time. So I realised that because I was starting the cuts from either side of the bar, I could actually start each of them at slightly larger than the required radius. So in theory the cutter wouldn't have any contact with the bar. Now I couldn't do that if I had to go around it all in one go, because stealing a bit on one side would have had the exact opposite effect on the other side. But as I said, because I was starting from each side, I really could have fudged the cutting radius a little bit and avoided that cutting in at the start. The faintest witness just on the end there. And I think that last one was possibly the best one, which is I suppose the way it should be. Right, well, let's finish the machining. Got all my ends rounded, and it's time to replace the plain nuts I used when I was doing assemblies with lock nuts, and see if it all comes together. So we'll start with the main pivot. This is the thing I made up with a 14mm across the flats hex built into it, and the spacer in the end so this tube didn't get squashed. Right, so looking at the 4 bolts that hold the column onto the column mounting block, a little detail which I didn't mention on the way through, I don't think. I deliberately set this block about 0.1 or 0.2 actually below the edge of the column, and the reason for that is that when it then gets done up, the bolts will pull the perimeter of the column tight against the plate to minimise any chance of wobbling. And of course I can do these guys up tight because there's a solid block there. So, and also it made it easier because the spanner access is a bit restricted here. So we put this fellow back on the column now. Sure, I think I said put the column back on the column. Obviously I meant put the column back on the base plate. Senior moments. My life's full of them. As you will have noted at various times through the this video. Anyway, as my dad used to say, don't let the things you can do stop you from doing the things you can't do. No, I got that wrong too. Don't let the things you can't do stop you from doing the things you can do. Anyhow. Anyway, give these a good... If these ever come loose, I'll put Loctite on them. I don't really think there's much chance they will though. Okay, so that's the column assembled. Moving on to the arms. Oh, another detail. I want the bearings to run as freely as possible. So these were actually supplied as sealed bearings with rubber seals. And I whipped them out, washed the grease out and put a very thin oil in instead. So we got these spacers here to in recognition of the fact the bearing is actually in the middle of this piece. So there's 1.5 mil from that bearing face to the face here, but then 3 mil clearance each side. So these things are 4.5 mil long. Now I'll put this fella on. These should all line up. Well, I had to backtrack a little bit there because I forgot the spacer that goes in there. I left it on the bench. That's there so that when I do the securing the pivot bolt up, it doesn't squish the centres of the bearings together. Right, so we'll try again. So I've got the spacer on that end, that's alright. I see my cricket friend has joined me again too. I don't know whether I mentioned this before or not, but I drill all my holes to the nominal size of the screw. So that's a 5mm screw and I use 5mm holes. I find with the DRO it's generally pretty easy to get everything to line up, as long as your twist drills don't wander off too much when you're drilling, because there's a bit of depth to go through here. But I think that's all alright. Now we've got to put a... Oh, I'll put a washer on. Why not? A lock nut on there, and I'll tighten that up in a minute, I think. Yeah, so we should be able to, yeah, I think we should be able to put this on now. Right, we'll have another washer on there, and there's a lock nut floating around that's supposed to go on there. I don't know, I have to go and find another one. Don't know what happened there. I'll stay. I don't want it to... God damn it. I don't want it to... Okay, let's turn him over. I don't want it to swing out if I've got everything done up. Nut. Found the nut. I walked out, I took it with me when I went over to get the spacer for some reason. Alright, so tighten a few things up. It seems to be fairly free swinging, doesn't it? I think I mentioned in the build thing that I made a pin that could go in there to make this thing act as a regular pendulum, so perhaps we'll use that for a moment to give myself something to hang on to here. Right. I think that's about it. I've done those up tight. So time for a bit of a test. Right, it's certainly free like that. Okay. I'll set it up and we see it do its stuff. So I said in the video description that this thing wasn't my design, and it certainly wasn't. I've included some links to show where the inspiration came from. I drew it up from the pictures that I saw in these links to fit the material that I had in the way I wanted to make it. Now the way I made it, of course, reflected the tool kit that I had and the way I wanted to do it, but you could easily have made the same thing pretty much just with hand tools and a drill. You really didn't need anything more to get a working model. I haven't gone into any of the maths to do with double pendulums. It's very complicated, I gather, and it's just a bit of fun. It's a bit of a toy. Anyway, if you made it this far, thanks very much for watching. Hope you enjoyed it, and I'll leave you with a full run of the pendulum showing its chaotic motion. Cheers. So with the pin still in, just acts like a regular pendulum, so not terribly exciting. You take the pin out, and that's what releases the chaos.